हेलो एवरीवन, वेलकम टू माय चैनल। आज हम लोग पढ़ेंगे आईजीसीएसई 10th केमिस्ट्री मिक्सचर सॉल्यूशन एंड सॉल्वेंट। ठीक है, तो पहले देखते हैं हम लोग मिक्सचर क्या होता है। मिक्सचर कंटेन मोर देन वन सब्सटेंस। ठीक है, द सब्सटेंस आर जस्ट मिक्स टुगेदर एंड नॉट केमिकली कंबाइंड। ठीक है, तो मिक्सचर में क्या होता है, दे आर नॉट केमिकली कंबाइंड but they are mixed each other. Like air is a mixture of nitrogen, oxygen, and a small amount of other gas. So in our environment, air is a mixture of different type of gases like nitrogen, oxygen, and a small amount of other gases like SO2, H2O. Like, and next example is shampoo is a mixture of several chemicals and water. So water is water, H2O, and some other chemicals that is called shampoo. Now look at the solution. When you mix sugar and with water, sugar seems to disappear, right? This is because its particles spread all over the water particles like this. So this is your crystal of sugar and this is your water. When we are putting sugar into water, so particles of the sugar is distributed, right, in the water. So the separation sugar particle are too small to be seen. So in this way, solution is formed. So right up to this point, now look at the next point. Sugar has dissolved in water, giving a mixture called solution. Okay. So when sugar is dissolved in water, then it will give a solution. So sugar is the solute and water is the solvent. So it will be solute plus solvent produce solution. Right. Now not everything dissolves so easily. Now think about chalk. If you mix chalk powder with water, most of the powder eventually sink into the bottom. You will get it out again by filtering. Okay. Why it is so different for sugar and chalk? Because their particles are very different. So how easily a substance dissolves depends on the particle in it, right? So it totally depends on the particles of it. Now look at the examples. The table compound like silver nitrate, mass having dissolved in 100 gram of water is 241.3. Now as we going down, mass is decreasing. Like calcium nitrate, sugar, potassium sulfate, calcium hydroxide, right? Now look at the example, a mixture of chalk powder and water. It is not a solution. The tiny particle, chalk particle do not separate and spread through the water particles. They still cluster enough to see. In time, most sink into the bottom, right? Now look at the next point. So silver nitrate is much more soluble than sugar, but potassium nitrate is not less soluble than sugar. It all depends on the particles. So look at the calcium hydroxide. It is only very slightly or sparingly soluble in water. The solution is called lime water. Now look at the two substances in the table. They are usually called insoluble since they are little bit dissolved, right? So what soluble does not? The solubility of every substance is different, but there are some overall pattern. For example, all sodium compounds are soluble. Find out more on the page of 160. And look at the next point, helping a solute dissolves. This is your sugar, this is your stirring rod, and this is your water, right? So sugar dissolves quietly slow in water at the room temperature. If you stir the liquid, that helps, but if you keep on adding sugar, so more sugar is more soluble in hot water than in cold, right? So soluble solid get usually more soluble as the temperature rises. A solution is called saturated when it dissolves no more solute at the that temperature. Right. Now look at the next point. Extra sugar sink to bottom. Eventually, no more of it will dissolve. No more how hard you stir. The extra sink to the bottom. The solution is now called saturated. Right. This is your heat. But look what happen if you heat the solution. Extra sugar dissolve. right? Add more sugar and it will dissolve too as the temperature rises, right? Now look at the next point, water not only the solvent. So water has the world most common solvent, a solution in which water is an aqueous solution. Yeah, from aqua, Latin word from the water. But many of other solvents are used in the industry about the house to the dissolve the substance that are insoluble in water. Like what? White spirit, right? Dissolving glopane, propanol, acetone, grease nail polish, ethanol, glue printing ink, the scented substance are used in perfume and aftershave. All three of these solvents evaporate easily at the room temperature. They are volatile. That means that glue and paints are dry easily. Aftershave feel cool because ethanol cools the skin when it evaporates. Right. Now look at what about volatile liquid? A volatile liquid is one that evaporates easily. This is a sign that forces between the particles are weak. So volatile liquids have low point 2, that is 56.5 degrees Celsius. Now look at the another example. Nail polish is insoluble in water, but it can be removed later by dissolving with propanol easily. Now our next topic is pure substance and impurities. So what is a pure substance? Look at the diagram. This is your water particles. Water particles. So white one is water particles. So colored one is mixed one. Okay. So this is a water has only water particles in it and nothing else. So it is called pure, 100% pure. Now look at the second diagram. This one. So this is not 100% pure. Some other particles are looking around, right? So now look at the next one. Third diagram. This water is a particles of harmful substance in it. It is not the pure, but it make it ill. So pure substance has no particles of any other substance mixed in it. That is the definition of pure substance. So in pure substance, no other substance will be mixed in it. It will be only one particle, right? So in real life, every few substances are 100% pure. For example, tap water contain a small amount of many different particles like calcium ions and sodium ions. Now look at the next point. In real life, very few substances are 100% pure. For example, tap water contains a small amount of many different particles like calcium chloride ions. The particles in it are not usually harmful, but some are very good for you. Distilled water is much pure than tap water, but it is not a still 100% pure. For example, it contains particle gases like dissolving. Right. So does purity matter? Often it doesn't matter if a substance is not pure. We wash in tap water, right? Without thinking too much about it, what is in it. But sometimes purity is very important if you are looking a few medical drugs or a flowering for food. You must make sure it contains nothing, but it could harm others. So unwanted substance mixed with the substance we want is called impurity. So what is impurity? An unwanted substance mixed with the substance you want is called impurity. Right? So they go next have baby food and milk powder are tested in the factory to make sure it contains no harmful impurities. Right? So getting ready for a jab, vaccine and medicine must be safe, free for harmful impurities. So they are tested heavily. Right? Now, how can you tell the substance is pure? Right? So chemists use some complex method to check the purity, but there is one simple method you can use in our lab. You can check melting and boiling point. So substance has a definite sharp and melting and boiling point. So they are different for each substance. So you can look them in the table. When a substance contain an impurity, its melting falls and boiling point rises. It melts and boils are over a range of temperature, not sharply. Right? The more impurity is, the bigger the change in melting and boiling point. The wider the temperature range over which melting and boiling point occurs. Right? So look at the sulfur melts at 119 and water at 0. So boils at 0 degrees Celsius and sulfur at 445 and water at 100 degrees Celsius. So this is the table which gives the melting and boiling point of sulfur and water.